Welcome to Education Hub, your go-to channel for insightful knowledge. Today, we're delving into the fundamentals of electrical circuits with a focus on one of the most essential principles, Ohm's law. Whether you're a student, an electronics enthusiast, or just curious about how electricity works, this episode is for you. Let's start with the basics. Ohm's law, named after the German physicist Georg Simon Ohm, relates three fundamental electrical parameters: voltage V, current I, and resistance R. The law is expressed by the formula V equals IR. Sounds complex? Don't worry, we'll break it down step by step. Voltage, measured in volts, represents the electrical potential difference across a circuit. Imagine it as the force pushing electric charges along the circuit. Current, measured in amperes, is the flow of electric charges. And resistance, measured in ohms, opposes this flow. It's like the speed bump in our electric highway. Now, let's put it all together. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided the temperature remains constant. Mathematically, V equals IR. This formula is the backbone of understanding and analyzing electrical circuits. Practical examples. Host. To make things more tangible, let's explore a couple of examples. Imagine a simple circuit with a 9-volt battery and a resistor of 3 ohms. According to Ohm's law, we can find the current flowing through the circuit using the formula I equals VR. Substituting the values, we get I equals 9V3, which gives us 3 amperes. Applications in real life. Ohm's law is not just a theoretical concept. It has countless real-world applications. From designing electronic devices to troubleshooting electrical problems, understanding Ohm's law is crucial. It serves as the foundation for engineers and technicians working in various industries. You dive deeper into the world of Ohm's law. Remember a few tips. Always use consistent units: volts, amperes, ohms, and be mindful of the units specified in your problem. Additionally, pay attention to the polarity of voltage and direction of current to ensure accurate calculations. And there you have it, Ohm's law demystified. We hope this episode has shed light on the fundamental principles governing electrical circuits. If you have any questions or topics you'd like us to cover in future episodes, drop a comment below. Until next time, keep exploring, keep learning, and stay curious. This is Education Hub, signing off.